I'm Kaini. I'm going to solve another question from past year paper. This is A-level past year paper. This is the code of the paper. It is 9709, paper 1, that is pure mathematics 1, variant 2, October, November 2018. Now, this question is on calculus and application of calculus actually. Anyhow, you can see that we have got a curve and we have a straight line, and there is a point on this curve and a point on this line. The question, I will read the question later. You can see this length can vary if we move it parallel to y-axis. They want to see how much the maximum value of PQ. Now let's see what the question says. The diagram shows part of the curve y equal to x, open bracket, 9 minus x squared, close bracket. This is this curve. And the line y equal to 5x. This is the line y equal to 5x. Intersecting at the origin O and the point R. Therefore, this is the point O and this is the point R. Okay, the intersecting at these 2 points. The point P lies on the line y equal to 5x between O and R, here between these two. Therefore, P is a point between these two, and x coordinate of the point P is t. Therefore, x coordinate here we are assuming is t. Okay, point Q lies on the curve and PQ is parallel to y-axis. Therefore, x coordinate of Q also will be t because it's parallel to y-axis. Therefore, x coordinate of P and Q is same. Okay, now he's asking us the first part of the question. Express the length of PQ in terms of t. Okay, simplify your answer. Okay, let us see. Okay, therefore, what is point P? Point P, sorry, let me use the black marker. Point P, sorry, x is t, therefore y is 5t, therefore P is t and 5t. Now, point Q, again x is t, but the y is, the equation is this, or this, doesn't matter. Therefore, the equation is this. Therefore, t, open bracket, 9 minus t squared, which is 9t minus t cubed. Therefore, point Q is t, 9t minus t cubed. Now, if we want to find the distance QP, it is sufficient to subtract the y coordinate of Q from y coordinate of P. Therefore, if I subtract this from this, I am going to get PQ. Therefore, the length of the PQ is equal to 5tq, sorry, this is Q, 9t minus t cubed minus point P, which is minus 5t. Therefore, the answer will be 4t minus t cubed. Therefore, this is the length of PQ in terms of t. Therefore, we could get the length of PQ in terms of t. So this part is done. Now, second part, it says that given that t can vary, find the maximum value of PQ. You see, if t varies, that means actually PQ changes. If t is here, PQ is this much. If it goes up, it will be like that. Therefore, PQ, this point, the distance, keep changing. He wants to find the maximum value of that. Okay? I will erase this. I need only this part, then I will copy it down there. Therefore remember, we have PQ equal to 4t minus t to power of 3. Now, for simplicity, let capital D distance denoted by, PQ denoted by capital D distance. Therefore, we have a function D is equal to 4t minus t cubed. So we have a function D in terms of t. Now we want to find the maximum value of that. Therefore, we have to differentiate D with respect to t and put it equal to 0. Therefore, we can say that D dash or d of dt is equal to 4 minus 3t squared. You know how to differentiate? This is 4t, therefore this is 4, this 3 comes down, reduce 1 from the power, therefore this is the differentiation. Put it equal to 0 to get maximum and minimum value, therefore we are putting equal to 0, 4 minus 3t squared equal to 0, you are going to get 3 is equal to 4, therefore t squared is equal to 4 over 3, therefore t is equal to plus or minus a square root of 4 divided by 3, which is plus or minus 2 divided by square root of 3. For sure, t cannot be negative because t lies between O and R, therefore t is positive. And you can check that also if you want to find the maximum value, second derivative, that means d dash dash or d squared d by dt squared should be positive. You can check that also. I will check that for you to make sure you are getting maximum value. You see, if you take the second derivative, that means d dash dash or d squared d by dt squared is equal to minus 6t, because derivative of this is 0, 2 comes down to be minus 6t. And then if you put the positive value, that means t, if you are putting the positive value here, therefore you can see that minus 6 times 2 over the square root of 3. I don't care for how much is the value, but I want to know the sign. Sign is negative, therefore second derivative is negative, so that the function at this point has got the maximum value. Okay, now let us find the maximum value. It is sufficient to put this inside this function to get d. That will be the maximum value of the function which we are searching for. Therefore, d will be equal to, put it here, you are getting 4 times of 2 divided by square root of 3 minus 2 divided by square root of 3 to power of 3, which is 8 over square root of 3 minus 8 over 3 square root of 3. Take the common denominator, this is 3 square root of 3. This will be 24 minus 8, which is 16 over 3 square root of 3. Therefore, this is the maximum value of d. Therefore, we have found the maximum value of PQ, which is we denoted by d. Therefore, we have found this. If you want me to solve any question for you, put them in the comment section below, and I can go through that, and then I will solve it for you and put it in our channel. Thank you for watching.